Hey, you guys, welcome back. Today we're going to go over combining like terms. Before we do that, though, fact number 26 about me. I've been a teacher for about 5 years now, and I really love it. This has been great. I've really enjoyed this. I'm so glad I've become a teacher and get to do this, especially with all you guys. This has been a great year already. Before I was going to become a teacher, though, my big dream, the big goal for me for most of my life, probably from the age of 8 to about 21, was to be a doctor. When I went to college, I got a science degree. More specifically, I got a biology degree. The things that you guys are learning in seventh grade science about cells and biomes, I got a degree in that because I really love that stuff. Life science was always really fascinating to me. And for all those years, the big plan was to be a doctor. However, that last year of college, I started to think and realize I didn't want to be a doctor. It was a long road. It was really difficult and competitive and tough to be a doctor. And if you don't really want it, like with everything you have and are going to devote all your time to it, it's probably not the field for you. A lot of you guys probably want to be doctors, and some of you will become one. But again, if you don't really want it and don't love science and don't want to devote a lot of your time to studying and getting better at that kind of stuff, it might not be the career path for you. But luckily, there's a million other career paths. Even just in the healthcare field alone, there's a ton of other jobs out there that you could do. So that was the plan for a long time. I'm ultimately glad it didn't work out because I've actually liked this a lot more. This is probably a better fit for me. But again, we kind of have these dreams, and as we get older, they change, and that's cool. That's okay. So anyway, let's get back to the math. Today we're going to talk about combining like terms. Now, when we talk about combining like terms, we have to, for one, know what like terms are. What does that even mean? Oh, wait, let me turn this back on. It kind of lost power. 1 second. There we go. So whenever we talk about like terms, we have to know what that means. So like terms are any two terms with the same exact variable raised to the same exact power. So x, let's say, you know what, let's just do an example because that kind of puts it into a better context. Let's look at this one, 5x and 7x. Those have the same variable and it's raised to the same exponent. There's no exponent written there, but when there's not an exponent, I know there's actually an exponent of 1. We just don't have to write it. So whenever I go and combine like terms, I'm talking about combining two things, right? I'm combining them. I'm adding them. So 5x plus 7x, when I add these terms, combine them, all I'm doing is adding the coefficients out in front. So 5 plus 7 gives me 12. And then I keep the x the exact same. This is just 12x. 5x plus 7x is 12x. Great. Let's look at the next one. Let me fix that x. There we go. Let's look at the next one. Negative 13y plus 2y. These are like terms because they both have y as a variable and it's raised to the same exponent. Again, there's an exponent of 1 even though we don't have to write it. So now to combine them, all I'm going to do is add the coefficients. And remember, a coefficient is the number right in front of the variable. So this has a coefficient of negative 13. This has a coefficient of 2. So I'm going to go and add those. Negative 13 plus positive 2 gives me negative 11. And then I keep the y the exact same. I just bring it straight down. Let's look at the next one. Oh, this has more terms. This has 1, 2, 3, 4 terms in it. So let's look at this. I'm going to go and combine all the like terms. Now when I do this, I'm going to put a little shape around the like terms just so I can see them really clearly. Negative 9x. I'm going to go and look for any term in this expression with that same exact variable of x. So we'll put a little shape around here, negative 9x, and then, 3x. Those are like terms. So negative 9x plus 3x gives me negative 6x. I just add the coefficients, negative 9 plus 3. And then I'm going to mark them out just because I don't want to get confused and think I still have to deal with them. Those are taken care of. So now I only have 4y. And is there a like term? There is 2y. 4y plus 2y gives me 6y. So that is combining like terms. And remember, whenever we're doing this, we call this ultimately, this is a method to simplify expressions. And the reason it simplifies it is because it takes it down from a certain number of terms to an expression with fewer terms. This had 1, 2 terms in it. Only have 1 term now. This has 1, 2 terms. Only have 1 term now. This has 1, 2, 3, 4 terms. And look, now I only have 2 terms. It's simpler and it's much more manageable and easier to handle that way. Let's look at the next one. 15 plus 8a plus 2a plus 9b. Let's go and look for the like terms. Let's see. I know 8a and 2a, those are like terms. I'm going to put a little shape around that. They're like terms because they have the same exact variable raised to the same power. So 8a plus 2a, I'll add the coefficients, the number out front, and I get 10a. I'm going to mark through these so that I know I'm done with those. Let's look at what's remaining. I have 15 and 9b. Those are not like terms. And the reason why is because this has a variable b in it. This doesn't have any kind of variable. This 15 is a constant. It's a number by itself. It's a number that's constantly alone, okay? It does not have a like term. Neither does this one. So watch what I'm going to do. I'm just going to bring them straight down. Plus 9b plus 15. That's as simple as I can make that expression. I can't combine any other things because there are no more like terms. Let's look at the next one. 4x squared. Oh, this has an exponent of 2. Let's look at this one. 4x squared plus 3x plus 9 plus x. So when I'm looking for a like term of 4x squared, a lot of kids want to say, oh, it's this. It's a 3x. Look, they have the same variable. But this is not a set of like terms. And the reason is because this 4x has an exponent with it. This 3x has no exponent. These are not like terms. And remember, there's no exponent of 1, but they all have it there. If there's no other number written, it's a 1. So these have different exponents. Those are not like terms. But you know what are like terms? These right here. 3x and x. But wait, there's no coefficient in front of x. If there's not a coefficient written, I know there's a coefficient of 1. All right, we just don't have to write it. So 3x plus 1x, that gives me 4x. I'm going to mark them off because I'm done with them. Then I'm left with 4x squared and 9. These are not like terms because this has an x squared and this one is a constant, has no variable. So watch what I'm going to do. I'm going to bring them straight down because I can't combine them with anything. 4x squared plus 4x plus 9. Now, you might be curious, why did I write them in this order? I could have written the 4x plus 4x squared plus 9 over here. Whenever we write these, there is an order. We're not going to grade it, at least not right. We're not going to grade on the order, at least not right now. But the first thing, the number that goes first, the term that goes first is the highest exponent. In this case, it's the x squared. That's the highest exponent. After that, it goes in alphabetical order. So 4x squared goes first because it has the highest exponent. Then x comes next. And then constants always go last. Constants are last. Let's look at the next one. Now this has some subtraction in it. Whenever we see a subtraction sign, we always change it into an addition sign. An addition sign. An addition sign. And whenever we do that, we also have to change the sign of the following number. So that becomes a negative 15y. That becomes a negative 3y squared. That becomes a negative 6y squared. And it's because whenever we used to call it this method, the keep change change method, and we still do that, except we're not really going to call it this anymore. Instead, we're going to say add the inverse, the additive inverse. That's because, let's give an example. 4 minus 7. You know, when you're in elementary school learning how to do this, you don't learn it this way because the bigger number is in the second place. 4 minus 7, you would just say, oh, we can't do that. It doesn't work. Now, we know negative numbers. So instead of 4 minus 7, we're going to say 4 plus negative 7. Oh, and we can do that. The signs are different. I would really, in my mind, think about subtraction and get negative 3. We do the same thing here because we know the addition rules. We don't know subtraction rules. All right, we don't talk about those, just the addition rules. So let's look down here. Negative 17y. I'm going to look for all the like terms. Let's see, negative 17y, negative 15y, they have the same variable. 3y squared, not a like term. It has an exponent of 2. Y squared, once again, has an exponent. So these two don't match these two over here. So this is a like term with these are like terms. So negative 17y plus negative 15y, that gives me negative 32y. I'll mark them off because they're done. And then 3y squared, negative 3y squared, don't forget that, plus negative 6y squared, that's negative 9y squared. Now you can either write it like this, or you could change it to addition and the sign of the following number. Or if you want to write it in the correct universal order, it would look like this. Negative 9y squared plus negative 32y. That's because the highest exponent goes first. Okay? But again, we're not grading for that right now. It's just something for you to keep in mind. Now I'm going to give this an erase. I'm going to scroll down. Okay? All right, let's look at these. Let's see, we just did number 6. Perfect. All right, let's start with number 7. So this one over here, 7k plus 9b to the third plus b to the third minus 2k. Remember, whenever I have subtraction signs, I change it to addition and change the sign of the following answer. So I'm going to go combine like terms. I have 9b to the third, b to the third. Remember, there's no coefficient here. There's no number, but I know there's a 1. That's 10b to the third. Mark them out because I'm done. 7k plus negative 2k, that gives me 5k. There's no more like terms, so I've combined it all the way. Let's look at this one. I always go and change subtraction to addition and the sign of the following number. Subtraction to addition and the sign of the following number. Now, I'm going to go through and combine like terms. I always look for the highest exponent first because I like to put that first when I write my new expression. So this y squared, that's the highest exponent. I'm going to go and find negative 9y squared, and that combines with negative 3y squared. They have the same variable and the same power. That's negative 9 plus negative 3, so I get negative 12y squared. Notice how I don't do anything with the exponent, I just don't forget about it. Okay, I bring it down with the y, it stays with it. And then 6h plus 4h, that gives me 10h plus 8. And that's all of them. That's as simple as I can make that one. Let's look at the next one. X plus 2y minus x, I change all subtraction to addition and the sign of the following number, plus 3y. And remember, there's no coefficient in here, but there's a 1. So now it's like a negative 1 is out in front of that x. So x, which has a 1 in front of it, 1x plus negative 1x, that works out to be 0. I'm not going to write 0x though, because that's really just a 0. This is multiplied together. Any number multiplied by 0 is 0, so I don't have to include it. Those just cancel out. And then I have 2y plus 3y. That just gives me 5y. Let's look at the next one. Change subtraction to addition and the sign of the following number. Subtraction to addition and the sign of the following number. Now, let's go find the highest exponent first. Let's see. 3 is the highest exponent. Negative 3x to the third. No like terms. I'm just going to leave it as is. No change. Let's see. An exponent of 2. And remember, if the exponents are the same, they both have a 2, I'm going to go in alphabetical order. So 5a squared, I'm going to put that first. Let's see, does this have a like term? That's 5a, but wait, they have different exponents, so they're not like terms. All right, so plus negative 5a squared, or you could leave it as minus 5a squared. This is the same exact thing, okay? Either way you write it, it's just fine. Again, the exponent comes first, so plus 4x squared plus 5a. Hey, there were no like terms there. All I'm doing is putting them in the correct order. All right? There was nothing to combine there. Not one thing. Let's look at the next one. All subtraction. I'm going to go change all to addition because we know the addition rules. And change the sign of the following number. So now, let's look for the highest exponent first. I have y squared, negative 9y squared plus negative 3y squared. That gives me negative 12y squared. Mark those out because I'm done. And then 5y, negative 2y, and negative 1y. Remember, there's no number, it's a 1. So I can only do 2 at a time. This gives me negative 3y. So negative 3y plus 5y, that gives me 2y. Let me rewrite this just so I have plenty of room. Negative 12y squared plus 2y. That is the simplified expression, that I'm looking for there. All right, let's look at the last one. 8v, let me go change all my subtraction to addition and the sign of the following number. Subtraction to addition, sign of the following number. 8b to the third power, negative 8b to the third power. Well, that cancels out. 8 plus negative 8, that gives me 0. Whenever the coefficients add to 0, I don't include them at all. So then I have 3b squared plus negative 5b squared. I'm going to add the coefficients, 3 plus negative 5. That gives me negative 2b squared. I keep the variable and the exponent exactly as is. All right. So again, that's combining like terms. We're taking a lot of terms and hopefully going to make them fewer terms because this is a lot easier to deal with. Okay. All right. Thank you guys for sticking around for the whole video, and I will see you guys in class tomorrow.